Velocity average is delta S by delta T. I mean, the displacement and delta T. Okay. Here, one thing is, required to know that if we want to calculate delta S, many a times we consider S equals to S1 equals to 0, or the initial S naught equals to 0. That is why actually maybe let's say delta S. Can you tell me, like, if I go a position, just a minute. If let's say my S1 is equals to 30 meter, S1 30 meter. So can you tell me, and S2 60 meter, meaning my original position was 30 meter from, let's say, the building or someplace, and I walked to 60 meter. What is my delta S?
60 to 30.
30, sir.
Delta S equals to 30. So do you understand, like, while we are using our equations, at that time we will be careful that our S means a position. Delta S means a difference of two positions. Okay?
Yes, sir.
This one you need to be careful. So then they have showed that how they become limit tends to 0. They bring it like that, like it can be calculus. It can be showed in this manner. And then we have one concept is here. The concept of this one, delta S, only the difference between two positions, not the entire path. We can do along with the path, that will be ST, difference with time. But if you consider only displacement of the displacement, then actually we can only see this difference, P1 to P prime. Okay, negative change. Oops. It goes. Okay, then we have count about average acceleration, delta V by delta T. Okay, if velocity varies from one position to another position, then what is the acceleration? Okay, this one I guess is very easy with you now. By this time, we also see that if we have this, this equation, like dt is equal ds by v, because v equals to ds by dt, if you remember, and a equals to dv by dt. So dt comes in one side, ds by dv, ds by v, and dv by a. This one is okay?
Yes, sir.
Okay. So this one, only this part, we can take as this, like this, a ds, a multiply ds, v multiply dv.
So this equation come from dt, sir.
This equation comes from dt. All equals to dt, that is why. This is just a technique to prove. Like you can say, do you remember, like we studied some upapaddo? So it's like that. So actually, this one you need to remember. For constant, here if you see that this is a constant acceleration. So this proof will be working for constant acceleration. This one is very important talk. Okay, this one you need to remember. Clear? Because when we'll be using this equation, if I say in your exam question that acceleration varies, then can you use this equation?
No, sir.
No.
It's only just constant acceleration.
Yes, acceleration should be constant. T may vary or not.
T maybe vary, sir.
T vary, of course. Otherwise, actually,
Yeah,
the velocity
sir.
will not change. So T vary, V naught is constant because V naught is original position. velocity, I mean, it's a past. So past cannot be changed. So past is always past. And then velocity will be, the new velocity will be only time dependent variable because acceleration is also fixed. Okay. So that is why if it is a constant acceleration, then we'll be using this equation. So make a note. Okay. Don't do the mistake here. Then we have also seen how we can prove this one, right? Ut plus half at square, because v equals to this one, and v equals to v naught plus at. So we multiply this dt in right side and then integrate s naught to s, 0 to 0, v equals to v naught plus at into dt. So by integrating we get this simply for mention constant acceleration. Okay, any question?
No, sir.
Okay, then for dt equals to, we have found this equation, if you remember, just before, like dt equals to dv by I mean ds by v equals to
Yes, sir.
dv
dt equal to
by a.
ds by v and dt equal to dv by a.
Yes, so that one actually like this, and then they have integrated from v to v, v naught to v, and s naught to s. Here is also constant acceleration. If acceleration varies, then does it work? Because if it is a variable, then there should be some dA to make it. As it is a constant, we keep it outside and do this one. So while we will be using the constant, acceleration should be required. If it is not constant, we cannot use this equation. Am I clear?
Yes, sir.
Yes, sir.
Okay. So this one is very important to know. However, we have already gone through this. Here is the problem. Number one, we have already done it, but I'm just repeating because go through together. So a car on the left, like this one, a car in the photo and in figure 2.2 moves in a straight line.
Sir, someone called him. Shoaib Rana maybe.
Yes. I cannot hear you, Sohel. Yes, sir. Now tell it. I'm telling you. Now I will go to that. This problem will tell you. You see that the car on the left in the photo and 12.2, this one is 12.2, move in a straight line. So if it is a straight line, we are rectilinear, we are in the study of this chapter, such that for a short time, its velocity is defined by, for a short time, velocity is this one, where t is in second. T is in second, and of course the velocity is in foot per second as well. Even we can convert, no issue. So determine its position and acceleration when t equals to 3 seconds. So now position is known or unknown?
The position unknown.
Unknown, because that is what
Position
we are
unknown, sir.
determining.
It's a position and
Acceleration,
Acceleration also unknown, sir.
both are unknown.
Also unknown, sir.
because we don't know the acceleration as well. So is it possible to use the constant acceleration equations?
No, sir. Sir, due
No,
to
because I don't know acceleration. What is the acceleration? See, if I don't know, how can we use the direct equations which are derived for, constant acceleration? We cannot, right?
Yes, sir. We can't.
yes, sir.
Additional note, you can say this one is for student note or to understand. If you have any equation like this function, then actually you need to do either differentiation or integration. This is the technique to understand in dynamics. I mean, when I was the student, I was also following this rule, that if the teacher give us the, function means what? Function means it changes with time, or it changes with respect to something like position or time. So if it varies, some variation comes in, for sure we should take the help from differentiation or integration. Do you understand the technique? This
Yes,
is
sir.
a clue for you. You can understand like that.
Okay,
Do you
sir.
understand, or should I repeat?
স্যার এইরকম ইকুয়েশন থাকলে আমরা ডিফারেন্সিয়েশন অথবা ইন্টিগ্রেশন করব।
But for something, let's say if I differentiate it, what you will get? Different thing. If I integrate, you will get different thing. So you need to know what to find out and for what. That is a different issue. But I am telling you, when I will be using straight down the equation, like ut plus half at square or v equals to u plus at, those type of equation, when I will use? When I will be knowing exact value and I will be knowing acceleration is constant. If someone gave you this equation type, like a function type, that this one varies up to this function, then we have an option, you see, like we can do the calculation. Because if I multiply dt with this, you see, like we can do the integration. If I derive it with along with the t, we can get a result. So usually this is a technique also to tell that yes, this one is actually, I am telling from a student point of view. As a teacher point of view, yes, we need to understand that if I am telling a path, meaning it varies with time. It is not a direct proportion. V is not directly proportional to the time. It has some variation. Like it is not that in 1t it will go like this, second t it will like go that, and there is a constant motion or something, constant time, because they have also give a glitch. They have also tell you moves in a straight path such that for a short time its velocity is defined. For a short time, what does it mean? In a long time it doesn't work. It will be very different. For a short time, it follow this rule. So if it is for short time, meaning actually we are integrating or differentiating, something like that, going to limits equal tends to 0, like this. These are the indication. Do you understand?
স্যার তার মানে স্যার আমরা যে গত ক্লাসে স্যার এই ম্যাথটা আমরা যে সিম্পল সূত্র ইউজ করে করছিলাম স্যার, s is equal to s naught plus v naught t plus half at square. This procedure was wrong sir.
মেবি ওইরকম করে করলে হবে।
আমি এখান থেকে একটু জয়েন হই, নাইলে আমি ঠিক শুনতে পারতেছি না। Yes. Can you tell me now?
Yes sir. স্যার এই ম্যাথটা আমরা গত ক্লাসে স্যার সিম্পল ফর্মুলা ইউজ করে স্যার করছিলাম স্যার। s is equal to s naught plus v naught t plus half at square. সেখানে স্যার আমাদের পজিশন ছিল স্যার 49.5 মিটার, কিন্তু স্যার আমরা যখন ইন্টিগ্রেশন ইউজ করে করি তখন স্যার আমাদের অ্যান্সার আসছিল 36 মিটার।
হ্যাঁ, হ্যালো। Wait.
Sorry, your voice is buffering.
Wait.
অফ করেন প্লিজ।
Can you hear me now?
Yes,
Yes,
sir.
sir.
Yes, sir, we can hear you.
Any echo? No. So can you tell me now? Yes. What is the question?
স্যার গত ক্লাসে স্যার আমরা এই
Yes,
ম্যাথটা
sir.
সিম্পল ফর্মুলা ইউজ করে করছিলাম স্যার, লাইক এস ইজ ইকুয়াল টু এস নট টি, এস নট প্লাস ভি নট টি প্লাস হাফ এটি স্কয়ার। স্যার তাহলে স্যার
ওটা দিয়ে রেজাল্ট আসে নাই দেখেন, নাকি ওটা দিয়ে রেজাল্ট আসছিল?
স্যার রেজাল্ট আসছিল
ভিন্ন ভিন্ন
রেজাল্ট
কিছু
আসছিল
আসছিল,
কিন্তু
স্যার।
স্যার ওই যে
ভিন্ন ভিন্ন।
ডিফারেন্সিয়েশন করে ওইটার সাথে মিলে না স্যার।
ওইটাই বলতেছি। এটা that the reason is because the acceleration here we don't know that it is constant or not.
Yes, sir. Repeat again.
So that is if we go like that, it may be okay. The result, if it is come like same, meaning the acceleration was constant, but that will be a proof. Do you understand?
Yes, sir.
Is there someone else taking the class at the same time, or your? I mean, I guess MD Jisat.
Yes, sir.
Is there anyone else taking the
No,
In your
sir.
group?
My class friend, another section class.
class friend? Okay.
Yes, sir.
Okay. So what I was telling you, that determine its position. If we have this type of equation and we are not sure acceleration is constant, if I have written determine its position and acceleration, then we are considering the acceleration is constant. But if not, we will be trying to find out in a integration or differentiation way, and that is also easy. That will be easier. You see, like this is the solution. If I want to show you, like coordinate system is fixed, origin is 0 at the car, position to right, 0 to right it is going, position V, see, position find out, coordinate system. What will be the coordinate? If you see 12.2, you see origin is this one, origin. Okay, it goes from some position onward, but they said at t equals to 0, s equals to 0, so position is 0 in the beginning. So here is the coordinate, it will come like this, 0, s equals to 0 when t equals to 0. Okay, so if you see the fixed origin O to the car positive to the right, they have considered the position coordinate extend from the fixed origin O to the car positive to the right. So right side we consider positive. Here another sign it will tell you, like this sign. You see, when you will be doing this type of sign, if you write, we will understand that you are taking the right side positive. Do you understand? Is it
Yes,
clear?
sir. Yes, sir.
Yes,
Yes, sir.
Yes, sir.
Okay. So position. Now finding out the position. First is position or not? First one you see position. Determine its position.
Yes,
Then
sir.
acceleration. So position. Let us find out position. Position. If you see here, V is a function of t. Time dependent function is given because this one is time dependent function, isn't it?
Yes, sir.
yes,
That
sir.
is given. That is given. So as it is a
Yes,
time
sir.
dependent function, so we can determine from v equals to ds by dt. So here you see, like they are also saying if it is a function of t, then we can find out with this. Since the equation vs and t, nothing, noting that s equals to 0 and t equals to 0. So we have v equals to ds by dt equals to, this is the v. So ds equal v multiplied by dt, just taking t dt equals to here. Then we do the integration. We have already talked about it. And when t equals to 3, s equals to 36 feet. For meter, if it is given in meter, you will be writing meter. That's not an issue, right? Then acceleration we need to find out. How to find out acceleration? Since v equals to ft, function of t, then we can determine with a equals to dv by. So now we will be differentiating this. That will become acceleration. Also right side positive. Okay. So dt, after integration, differentiation, we get 60 plus 2. So when t equals to 3, a equals to this.
Yes, sir.
Okay. So the formula for constant acceleration cannot be used to solve this problem because the acceleration is a function of time. Here you see acceleration is 60 plus 2. So time variable here. If it become directly only 6, then acceleration is constant. Let's say if the function is not t square, can you tell me, if I tell you that okay, this equation is 3t plus 2, what is, or 2t, let's say 3t, okay, 2t will be again 5t.
Yes,
So
sir.
if this is my equation, then what will be the acceleration?
3.
3, sir.
Only 3, sir.
Only 3. Differentiation করলে only 3. So only 3.
11,
So
11, sir.
yes,
So then the acceleration is 11 because we know that t is equal to 3 and then find out
no. Hey, okay, that one is fine. I am saying this one as v, not a.
Sir, this one B. B, that's why
Equals.
differentiation.
So differentiation we need to do dv by dt at the time after equation.
3.
After this you will find 3, I guess, isn't it?
Yes, sir. Yes, sir.
Yes, sir.
Yes. So by at that time acceleration is constant. If you find that, you can say that okay, we could use the equation v equals to u plus
Plus ACT. Yes, sir.
at and something and something. Okay. Otherwise, as this is a time variant, time dependent, we will not use direct equations. Okay.
yes, sir.
Okay. So the same result, you see, like they have also said, the same result can be obtained by evaluating a constant integration c rather than using definite limits on an integral. For example, integrating ds equals to dt square plus 2t dt yields s equals to t cube plus t square plus c. So if you can solve this c, you can also find it out. We will not go that complexity, because I guess it is easy for you now already. Then we have also, oh no, this one we didn't see. Okay. Only this one we have done last day? Only this one?
Yes, sir. Only
Yes,
this.
sir.
Okay. So next is, I will not let you do the, okay, I will let you do this one. This will be, I mean, giving you another idea for equation. So here if you see, a small projectile is fired vertically downward into a fluid medium with an initial velocity 60 meters per second. So what happened? A projectile, do you know projectile? Like dheel,
Yes,
like
sir.
a brick, stone.
Yes,
Okay,
sir.
you throw it in the water. So what will happen? It will drop on the water and then go down, right? So they said a small projectile vertically downward into a fluid medium, downward vertically with an initial velocity of 60 meters per second. So initial velocity we have,
V0.
okay,
First
v0. Due to the drag resistance of the fluid, the projectile experiences a deceleration. So what will happen is, will it continuously increase its speed or decrease?
Decrease.
Decrease, because it's a
Decrease, sir.
fluid medium. So
Decrease.
medium will be resisting it. Okay. The deceleration is a equal minus 0.4 v cube meter per second square. This is now velocity dependent. Acceleration is velocity dependent, not time dependent. It is velocity dependent. Where v is in meter per second, determine the projectile velocity and position after 4 seconds after it is fired. So what will happen? You will you will find after 4 seconds what is its velocity, what is its position. You have initial velocity and you have the acceleration function. So if I have function, what should we do?
So
Directly
integration
to
Integration or differentiation.
Integration or differentiation.
coordinate system they have considered, you see, since the motion is downward, the position coordinate is positive downward. So what they are taking? They are taking positive downward. So you see, they have written here positive downward. Okay. So is function of v, so we must determine the velocity as a function of time using a equals to dv by dt. Okay, since the equation relates va and t, why not use v equals to v naught at? Why we don't use? This is a hint.
Like acceleration
Because
dependent
this
to
is
velocity, sir.
acceleration but constant, sir.
This is not constant. This is a function, meaning acceleration varies. So separating the variables and integrating, okay, with v naught equals to 60 meter per second when t equals to 0. At the beginning it was this, right? So at the time t was 0, else. So downward positive, acceleration equals to dv by dt. So here we know a equals to minus 0.4 v cube given in the example, given in the question. Clear? This one is clear?
Yes, sir.
Yes, sir.
Yes, sir.
Here, then what can we do? We take it other side, dt will go in right side. Minus 0.4 v cube will come left side, dt will come right side. So here you see, this one come below and dt goes on right. And we integrate 0 to t and 60 meter per second to velocity. We don't know v. We know t, right? After 4 seconds, we need to find out. So you see only one variable v will come here. How? Let's see this one. Do you know dv by v cube? Integration of dv by v cube. No.
Yes, sir, we know.
Yes, sir.
How
Yes,
do you
sir.
know? I mean, what is it? Integration will be equal to integration of this one dv by v cube. Integration will be considered as v to the power
Sir, minus 2.
Minus 3
Yes, sir, minus 3 plus
divided
1.
by
dv.
Sir, 1 by v square.
We need to integrate. Int. Int. Right? This will be the actually the problem. So minus 3 will be n. So we know 1 divided by equation will be equal 1 divided by 1 divided by n plus 1, right? Minus 3 plus 1. So it will be minus 2.
minus 2, sir.
Okay.
Minus 2.
Into
V to the power minus 2.
v to the power also minus 2.
Sir, 1 by v square.
1 by V square, sir.
Yes. 1 by v square or v to the power minus 2.
Minus 2.
Whatever you write. Okay. This one will be the integration. So previously we had this one. The I mean minus 0.4. So minus 0.4 come as it is. Then we also get 1 divided by minus 2 divided 1 by v square. So this one is correct also. Understood, everyone?
Yes, sir.
So dt is equals to directly come t to the power 0 to t. So t minus 0 and 1 minus 0.4 into 1 minus 1 divided by minus 2. This minus minus will be plus and 0.4 multiplied by 2. This 1 by v square will be v square minus 1 by 60 square. Everyone clear this one?
Yes, sir.
Yes, sir.
Okay. So now V equal, because we have only V square we require, let's take it in the other side. Okay, and I mean 0.8 will be multiplied with T. 0.8 will be gone to T. This one you understand? 0.8 as multiplied here.
Yes, sir.
So this will go with T. So this will become 0.8T. And this one as minus here. This one is waiting here as minus. So it will go and make it become positive. Positive plus this one. So we have 1 by V square. So what will you do? You reverse it, root over. So become minus half. Up to here is fine.
স্যার একটু ভাঙিয়ে দেখালে ভালো হতো।
ভাঙিয়ে তো দেখালাম।
So minus half-টা বুঝি নাই স্যার।
মাইনাস হাফটা দেখেন 1 by v স্কয়ার, এটা বুঝা গেছে? 1 by v স্কয়ার যে
Yes, sir.
Yes, sir.
বাকি যেটা আছে 1 by 6 স্কয়ার প্লাস 0.80, এটারে আমরা ধরে নিলাম d। আচ্ছা এটা বাদ দিই। এই লাইনের পরে দেখেন 1 divided by 0.8 equals to এটা। তাইলে এটা হয় কিনা দেখেন 1 by v to the power minus 2 minus 1 by v square minus 1 divided by 60 to the power 2. ভুল লিখছি তো। This one equal 0.8t. Is it okay now?
Yes, sir.
Yes, sir.
Everyone agrees? 1
Yes,
by
sir.
v square minus 60 square equals to 0.8t. So I will take this one also in the right side. Everyone agrees? Any problem?
Okay, sir. 0.8t multiply.
Become this one plus this. Everyone agrees?
Okay, sir. Yes, sir.
Okay. We have only 1 by v square. So what can we do? We just, alter it. Everyone will be altered. Meaning, this one will be v square equal 1 divided by this one. Do you agree?
Yes, sir.
Yes, sir.
All understood?
Yes,
Yes,
sir.
sir.
So if we have something square, we can just square root.
Yes, sir.
Okay. So I will take it as it become actually on the other side, it become half. I will make it again. Equal v equal this all this equal square root control V this. Now do you agree?
Yes, sir.
Okay. So as it is 1 by something, we can write down minus half, because this one is half anyway. Okay. Square root actually can also be written like this.
Half.
Also be written like this. All to the power half 1 by 2. You know that.
But here minus half.
Because
sir.
minus half, because this is 1 divided by. So here,
Okay, sir. Okay, sir.
that is why. If you write down 1 divided by, then it's okay. If you don't want to write this one, 1 divided by, then it becomes. Okay? Is it okay now?
Okay, sir.
Yes, sir. Okay.
So then, if I put down the velocity t equals to 4, then you get the velocity because only t is unknown here. If t equals to 4, you get what is v. So v become 0.555 meter per second positive. As it is positive, it become downward because we take positive as downward. Is it okay now?
Yes, sir.
Yes, sir.
Now, as we know velocity equals to like this, then we can just make it differentiate
Yes, sir.
very easily. Okay, or sorry. ds by dt. So we will make it integration. Yes, equal to ds by dt equal to this. This is the velocity. So as this is a t variant, time dependent, so dt will be multiplied with here and ds become 0 to s because 0 counted as in the position 0 as it is. What happened?
Sajid bhai.
Okay, so here ds equals to 0 to s and this one become just integrate, so s equals to 2 by 0.8 because this one, I mean, what to say, this half square root, this one is square root minus square root. Yes,
Sir, excuse me, sir. I have another class. Time is already up, sir.
Okay. So I guess I am not going deep into the integration. You can do it by yourself. So when you will be finding it out, then we will be using t equals to 4. After that, we will get the s. Okay, as
Yes,
you have
sir.
the book now, you can just continue
Okay, sir.
that.
We will try
part.
at home. This man.
Yes, sir.
Yes,
Yes.
you can try at home. So sorry. I will
Take your attendance, sir.